Hi, this is Trisha, and I'm going to show you how to do a bend calculation from start to finish. I'll go ahead and draw the pieces that I'm talking about, and I recommend that you do the same. So we're going to start off with a make-believe piece that's 14 inches long, and I'm going to bend it down the middle. So I like to go ahead and just draw a flat piece that's going to represent that. And I am using graph paper just to kind of help me draw the lines, and it looks a lot neater. So I'll just quickly draw that out. And if you need a little time to do the drawings, you can go ahead and pause the video and then catch up with me when you're back done. That would be fine. Okay. It's good to make it look realistic here. I'm going to go ahead and just draw. Let's see, I've got 1, 2. Let's see here, like this. So I'm going to say that the total piece is going to be 14 inches, and like that, with our extension lines. And then we'll say that each part here is 7 inches. Okay, now we're gonna, let's also say that the plate thickness is 1/4 inch. So I'll just put that down here, 1/4 inch plate thickness. Okay. Now I'll go ahead. The next thing we want to draw is the 90-degree representation of this plate, and then let's talk about the different ways of naming the dimensions that we're going to be using. So first I'm going to go ahead and just draw a 90-degree and make that, try to look as realistic as possible. It is a lot easier to do this in pencil. However, a pencil doesn't always show up very well when I'm making this video here. So anyway, I'm going to go ahead and draw some extension lines while I'm doing this. Okay, so we know our plate thickness is 1/4 inch, so I'll go ahead and write that in right there. These numbers here, they represent our desired dimensions, and so that's what we're going to find in the middle here, or in the inside of this bend. Go ahead and draw some more extension lines. Okay, now I'm going to go ahead and use a different color to represent the theoretical lines. And so the theoretical lines are, in theory, what would this outside dimension be from this point to this point? And the reason we want to know the theoretical is because we cannot get adequately the ruler inside here to measure from this point outward because of this radius. So it's much easier to take your combination square, line it up along this side, and measure from this point to this point, and then the same for that side. But we need to note that this side is going to be longer. In fact, it's going to be the desired amount, which is 7, plus the plate thickness, which is 1/4 inch. So our theoretical side will then be 7 1/4, and that's going to be also for this side. So we've got 7 1/4 inch Okay, so again, this is our theoretical dimension. Okay, and in theory, if we bend it at 90, we should get 7¼ inches on both sides. Now, what actually happens is metal does not always do what you want it to do, and depending on where it's made, the grain might be different from one piece to another. So we always want to do a practice bend so that we can test to see where the change is, if there is any change. So I'm going to go ahead and give you some actual dimensions, and again, I'll use a different color to help you see the difference in the numbers. It does get a little confusing with all these different numbers and keeping them straight, and so if you can remember that these inside or these numbers here, these are our desired dimensions. Okay, and then again, after you make the 90-degree bend, in theory, or the theoretical dimension should be the desired plus the plate thickness. Now, the third set of dimensions are going to be the actual dimensions. And like I said, I'm going to give you those dimensions. So after you bend it, let's say that the actual dimension over here is going to be 7 3/8. Okay, so from this point here, I'll go ahead and extend that line from here. Instead of 7 1/4, we have 7 3/8. Okay? Okay. Now, let's say on this side over here, we don't get 7 1/4, nor do we get 7 3/8, but instead we get 7 3/16. So again, I'll extend these lines. Okay. So 7 3/16. Okay. So, you know, this could be quite perplexing because we thought we were going to get 7 1/4, but in actuality, we're not going to get that in most cases, and unless you've done these and made your adjustments. But sometimes in theory, just doesn't work. Anyway, now one last thing we want to do is we want to mark our sides, and what we want to do is somehow mark it, and you can mark one side or mark both sides. Usually what I do is I'll mark one side my side and the other side machine side. So I'll go ahead and turn this here. Okay, and what that helps me keep track is when I bend the metal, I can keep track of the side that, say, you know, this side, oops, we lost our light. Okay, so let me backtrack. So we put the metal in the machine when it's flat, and the side that I can see, I call the my side. The side that when the press comes down, this back side is going to be the machine side. And if you want to do front and back, that's fine too. But I use my and machine sides. And it is helpful to mark them in some way because you can see that the growth or the loss is different. You know, so what we're going to have to do is make some adjustments based on the information from this practice bend. And then once we make the calculations of, you know, if it grew or if it compressed and we lost metal, then we make adjustments and then bend it again to see if it will come out to the desired amount, which is 7 in this case, 7 on both sides. So before you would then go out in the shop, you're going to do a little bit of math. So what we'll do here is we're going to look at the difference between the actual dimension and the theoretical dimension. Okay, now this is a great review of fractions because you're subtracting, you're finding the difference. And remember, when you're subtracting fractions, you want to have a common denominator. And so this is just a little mini lesson on how to do that. Or hopefully we don't have to go through it thoroughly, but I'm just going to go ahead and write these out. That's my theoretical, and I'll go ahead and subtract from that my actual. So we want to find a common denominator. We're going to change this to eighths. So that's 7 and 2/8, and then we subtract 7 and 3/8, because again we want to find the difference between the two. Now you will note in this case, if we subtract 7 and 3/8 from 7 and 2/8, we're going to get a negative 1/8. Okay, so what that is telling me is that we went from a smaller size to a larger size, so it actually grew. Okay, so we had a growth of 1/8. Okay, so on this side we had a growth of 1/8. Now over here we want to do the same thing. So maybe what I'll do is I'll put my side here. Okay, and now I'll put machine side over here. And again, you know, it really doesn't matter which number you put first. And this one, I was thinking after I just did this is probably confusing because, you know, I'm changing a negative eighth to a positive eighth. But if you understand that this was the number that I started with, and the number that I ended with is larger, after you can see 3 is larger than 2, that even though this is a negative 1/8, that's because of how it's written here, but really what's important is that it grew 1/8 because this number is going to be larger than this number here, which is 2/8. Okay, so hopefully I didn't confuse too many of you there. Let's do the same thing. We're going to take 7 1/4, and we're going to subtract from that 7 3/16. Again, that's my theoretical, and this is my actual dimension. And we're going to go ahead and convert fourths to sixteenths, so that's going to be 7 4/16 minus 7 3/16. And of course we get 1/16, that's a positive 16th. Now notice here that even though our answer is a positive 16th, our actual 16th is less than our theoretical. So we actually lost a 16th. Okay, so lost 1/16. Okay. All right. Now, if you think of, well, which number's bigger, you could certainly do that. You can decide, okay, this number's bigger, I'm going to go ahead and subtract it. So let me just show you another way you could write this out, because this might be confusing the way I'm showing you here. So here's an alternative. Just decide out of these two numbers which is bigger. Well, this one's bigger, so I'm going to go ahead and write that first. 7 3/8 minus 7, and we know that's 2/8. Okay, so we get 1/8, a positive 1/8, which is what we have here. Okay, and then again on this one here, we know that the 7 1/4 is larger because that's going to be 4/16. So and that's pretty much how we have it right here. Okay, all right. Anyway, it doesn't matter. That's what I'm saying. It doesn't matter how you set it up. What matters is that you think about the size from where you're starting to where you're going. Is where what actually is that bigger or smaller than the theoretical? That's what's the most important. Okay, now we're going to use this information right here. okay? We're going to use that to determine what our new plate is going to be, at what dimension it's going to be cut at, okay? Do we leave it at 14 inches, and do we leave the bend line in the middle? I don't think so, because when we did that, we didn't get our desired amount, okay? Theoretically, it should have been 7 1/4, but we got 7 3/8 and 7 3/16. So we need to make some adjustments. What we'll do now is focus on the total change, okay? So what we're going to do is take our growth here, so we have total change, okay? So we have a positive 1/8, and we had a loss of a 1/16, okay? Now this, of course, is positive 2/16 minus 1/16, and really we're just subtracting a 16th, and so we get a total growth of a 16th, okay? It grew a 16th growth, okay? So to account for that growth, we're going to go ahead and take away a 16th from 14, okay? So let me go ahead and we're going to draw another piece here, and I'm just going to do a little sketch. Okay, so we're going to take 14, excuse me for moving things around too much. So we're going to take 14 and we're going to subtract a 16th. Okay, so again, if you're still practicing with the fractions, we're going to convert this 14 to 13 and 16 sixteenths. Remember, 16 divided by 16 is the same thing as 1, so 1 plus 13 is in fact 14. We're just changing the way it looks, and then we'll subtract for that 1/16. And that will give us 13 and 15 sixteenths. Okay, this is our new total, or new length, I should say. And I'll go ahead and show that up here. So 13 and 15 sixteenths. That's what this new dimension is going to be. And we'll go like this. I guess we'll go here. Alright, I guess, there we go, make it look official. Okay, now, since we made some adjustments to the total length, we also need to make adjustments on where this bend line goes. And so I'm just going to go ahead and write in, this was, let's just make believe this was the my side and this was the machine side. Okay, so if we had a growth of an 1/8 inch, and what we want to do is account for that growth by taking away an 1/8 from the 7. Okay, so I'm going to make my adjustments over here. Adjustments. Okay, so for my side, I'm going to take 7 and subtract 1/8. Okay, again, I had an 1/8 too much, so I want to account for that growth by taking away an 1/8, and then I'll mark where the bend line goes. So I've got 7, that's going to be 6 and 8/8, minus 1/8 is going to be 6 and 7/8. So the my side is going to be 6 and 7/8. Okay, now the machine side, let's go back over here. When we bent it at 7, we actually lost a 16th. Okay, so to account for that loss, we want to add a 16th to 7. So again, I'll write that out. Machine side Sorry for that sloppiness. So 7 plus a 16th, that's easy, that's going to be 7 and a 16th. Okay, so that's going to go up here, 7 and a 16th. And so this side's going to be a little bit bigger. Okay, this is the machine side. Okay, all right. Now, here's the trick. You're not done. You want to double check. You want to make sure that this is going to work. We know that our total length, new length, is 13 and 15/16. We've just calculated the adjustments for both my side and machine side. It's a good idea to go ahead and add these two up to make sure they equal 13 and 15/16. And so, you know, I always recommend go back, look at your work, and then, you know, make sure it's right. So we'll go ahead and just add these up, 7 and a 16th plus 6 and 7/8. That's gonna we're gonna change that to 16ths, making that 6 and 14/16, and then 7 and a 16th. I'm gonna bring down, and then that will give us 13 and 15/16, which is what we have here. So I feel pretty confident that I did the math correctly. Please note that, you know, there's a fair amount of drawing here, so when you're working on these homework assignments, more detail is definitely going to help you keep track of all the numbers. Notice how I'm labeling what I'm doing, working on adjustments, and then drawing my new picture here, just to help me visualize and see what the numbers actually mean. Well, anyway, I hope this helped. Thank you very much.